First of all, we will design the body of the butterfly wall assembly. The dimensional views are given here, so we'll make use of that. So here I go, start mechanical design, part design. I will enter the part name as body and select the sketch tool, select horizontal plane, and I have two circles in that horizontal plane. Okay, now dimension of bigger circle is 140 in radius, so 140 radius. Then I will draw the next concentric circle with the same center, place the dimension, and the dimension of the inner circle is 194 in diameter. So change the dimension type to diameter and it is 194. Okay, so radius of the outer hole is 140. Okay, so 140. Yes, these are my two circles. Let's check the dimensions. Radius is 140 and diameter is 194. So radius is 140 and diameter is 194. So both the circles are green in color. That means I have completely constrained my geometry. I can exit the sketcher. Now I want to add the material. I will add the material in one direction, and the depth of that material can be seen in this side view. It is 225 in total. I will add only half of the material in upper direction, so 225 divided by 2. Okay, next I will select the upper surface as the sketch plane, fit in all. The next feature will be these three features which are symmetrically distributed about the axis of the cylindrical feature. I will complete the profile first and then I will decide the size. So here is my profile. Common tangent tool is taken from the sketch tools toolbar. Okay, this is my profile. Now I will align center of this arc with the horizontal axis using coincidence constraint. Next I will dimension the radius. The radius of my arc is 50. So I will edit the value to 50. Next, the distance of center of this arc from the axis of that cylindrical feature is, let us check what it is. It is 175. So I will change the value to 175. Now this is not horizontal. Let us make this line as horizontal by applying the constraint of horizontal. Now I will project this edge using project 3D elements tool from operation toolbar. Now I can trim the unwanted part using quick trim command from operation toolbar. Okay, I don't want this, I don't want this, I don't want this, I don't want this. Now there is one hole concentric with this circular arc. So here is the center of my circle. I will give the dimension. Now the diameter of that hole is 47. So I will edit the value to 47. Now all the elements are green in color. My drawing is completely constrained. So I can exit the sketcher. Now let us add the material using pad tool from sketch based features toolbar. I want to reverse the direction of material addition. So that is done by selecting reverse direction from pad definition dialog box. The depth of material addition is 32. That can be seen in the side view. It is 32. I will change the length of depth addition to 32. Okay. Now there are two more features which are symmetrically distributed. For that I will go to the transformation toolbar, select the circular pattern tool. Number of instances are 3 and I will select the parameter as complete crown because all the three features are distributed over the full circle. Then I will go to the reference element and select this face as the reference element and OK. Now let us select this object and make use of mirror tool from transformation toolbar and select the mirror element as this surface, lower surface. Okay, I am done. Now again I will select this component, mirror. So let us repeat this. I will mirror all of the elements one at a time. Okay. So I am selecting my component, mirror. I want both the components. Okay. So part body, object, mirror, and the sketch plane, mirror. Come on. Yes, I have done. So this is my geometry. Just go to the isometric view. The next, I have one circular feature on this plane which is at a distance of 160 from center. So I will produce that plane first. So let us select the reference plane for that. So I will select this plane as my reference. Go to the reference elements and select the plane tool. Change the direction of offset and it is 160. Okay. So I have my plane with me at 160, and on that plane I have this circular feature having diameter of 200. Okay, so let us draw that. Sketch tool, this plane as the sketch plane, my circle whose diameter is 200. Right, let us check. Yes, the diameter is 200. So I will make this center coincide with the origin using coincidence tool. I can exit the sketcher as my sketch is green. Let us add the material using pad tool. I have to add the metal up to the cylindrical feature. So under type, I will select up to next, and here I am done. Now again, on the opposite side, I have one circular feature having diameter of 75, and that is its profile can be drawn on a plane at 325 from this extreme left hand side plane. So let us generate that plane first. So I will select the reference, this plane or surface, and go to the reference element and select the plane tool. Reverse the direction of offset, and the total distance of this plane from this is 325. So offset is 325. Now let us select this new plane as the sketch plane. Sketch tool. Now I have circular feature, so I will draw the circle at the center of this origin. Diameter of the circle is, let us check, it is 75. So we'll change the value of diameter to 75. So I can exit. Now I will add the material using pad tool in the opposite direction and up to the next. Okay, so I have done. And this, we will make this hole whose diameter is 100 and depth is 25. So let us select that surface as the sketch plane. Go to the sketch tools, fit in all, circular element having diameter of 100. Okay, exit. And now to remove the material, I will use pad command from sketch based toolbars. The direction is correct and the depth of material removal is 25. So I will change the value to 25. Okay, done. Now there is one more hole. You can see smaller hole having diameter of 56.2. Okay, and that hole is up to this. Okay. So if I select this plane, the material removal length of that hole will be 310. So let us select that plane. Diameter is 56.2. So this surface will be my sketch plane. Sketch tool, circular feature, draw the circle at center, place the dimension. It is 56.2. So diameter is 56.2. Right, exit. And now we'll use the pad command to remove the material up to the length of 310, correct? So we'll change the depth as 310. So this is my hole. Okay, this is my hole. The next, on this cylindrical feature, there are these three holes having diameter of 20.3 and 15 deep on pitch circle diameter of 150. So select this surface as sketch plane, go to the sketch tool, draw the circle whose diameter is 150. This is my pitch circle diameter, and this circle is concentric with this one. So I will apply the constraint of concentricity. I will draw the smaller circle for hole. Diameter of that hole is, let us take, it is 20.3. Let's change the value to 20.3. Okay. The center of this hole lies on this PCD. So let us apply the constraint of coincidence, as well as center of this hole lies on this vertical axis. Again, coincidence. Now this PCD is my construction element, so let us select that circle and convert it to construction elements from sketch tools toolbar. Now my circle is whole, I can green, I can exit. Use the pocket command to remove the material. Depth of material removed is 15. Okay, let us change the value of 15. So here is my hole. Now there are three such holes uniformly distributed about the central axis. So go to the transformation toolbar, select the circular pattern tool, enter number of instances 3, and change parameter type to complete crown, and select the reference element as this circular element. Okay, so this is my first component of butterfly wall assembly body. Let us save this. Go to the file, save, name the file as body, select a new folder and save it. Okay. Now we will draw the second component in shaft, which is the revolving feature having 1, 2, 3 and 4 steps. So I will draw the profile for the revolving feature. This is my first step, this is my second step, this is my third step, okay, and this is my fourth step, right? So let's give the dimensions. Okay, this line is in line with this, so let us apply the constraint of coincidence. Now I will give the dimensions. Length of first step is 28.9. Change the value to 28.9. And length of second step, it is 89.8. So this is 89.8. Okay, and length of third step is, it will be visible in the side view, this bottom view, it is 24. So 24, and length of last step is 38.2. I will calculate it. 38.2 plus 193.8 plus is 15.1. So 247.1 is the total length. 247.1 is the total length. So I have done. Now I will specify the diameters of the circular features. So diameter of first feature is, you can see here it is 37.5, so radius will be divided by 2. 37.5 divided by 2. Next radius, okay, let's check, it is 56 diameter, so radius will be 56. Let's check again, it is 56, so radius will be 56 divided by 2. 56 divided by 2. The diameter of third step is it is 87.2. So radius will be 87.2 divided by 2. Okay. Now I am done. Geometry is in green color. It is constrained. I can exit the sketcher. I will use the shaft tool from sketch based toolbars. I will select the axis of rotation as this H axis, and here is my shaft. Okay. Now for this shaft we have one chamfer here whose dimension is 3 into 45. So I will select that edge to be chamfered. Okay. And go to the dresser feature, select the chamfer tool and enter the dimension as 3 by 45. Okay. Now next is this rectangular slot. Okay. So for that, go to the sketch tool, select this vertical plane, like the sketch plane. This is my triangular element. Length of that element is, I will check it, 193.8. So this is 193.8. Depth of that rectangular slot is 31.1 is the depth. So this is 31.1. Now what I will do, let us project 3D elements. Go to the operation toolbar, select project 3D sellout edges. This is a circular element. Okay, I don't want this, so delete. This is my construction element. I've converted it to the construction element. Select these two edges and make them coincide. Okay, now distance of slot from this edge is upon the linear distance. So distance of this edge from edge of this slot, it is 15.1. It is 15.1. So I am done now. I will exit, and now let us remove the material using pocket command. I will remove the material on both the sides using mirror extend tool. Okay, throughout. So this is my rectangular slot. Now on this rectangular slot there are two holes with a diameter of 12.5 throughout holes. So we'll select this as the sketch plane. Okay, now let us draw two circles. The diameter of the circle is 12.5. Okay, now I will draw one more circle. Diameter of the circle is also 12.5. Okay, 12.5. Now axis of this circle is aligned with this vertical axis. So coincident. We'll do the same with this circle, align with this axis, coincidence. Now distance between these two circles is specified. It is 100. Okay, distance between these two is 100, and this hole is located at a distance of 46.9 from the edge. This one 46.9. So 46.9. So I will exit and pocket, reverse the direction and throughout up to last. Okay, now I have done. This is my shaft. So let us save this, then we will draw the next component. We have to save all the parts in the same folder. Okay, the next part is the retainer, which is the circular feature. So let us draw a circle in the horizontal plane having diameter of 200 millimeters. So here I go, start mechanical design, part design, and name of my part is retainer. Select the sketch tool, horizontal plane as the sketch plane, circle at the origin, dimension is 200 in diameter. Okay, so 200 in diameter, and depth of extrusion is 25. So exit the sketch, add the material. I will add the material symmetrically about both the sides of the sketch plane. Total depth is 25, means I will have to add half of the material on both the sides. So 25 by 2. Now next, there are 3 holes having diameter of 20.3 on PCD of 150. So I'll select this as my sketch plane, sketch tool, circle at the origin, place the dimension of the circle, and that dimension is 150, the pitch circle diameter of those holes. Now circle and diameter is 20.3, so diameter is 20.3, and this circle is coincident on this vertical axis. So I will select the center of the circle and the origin, vertical axis, and give the constraint of coincidence. Next, so it has gone on the origin, so I will repeat this vertical axis. We'll remove this constraint which was taken automatically. So center of this circle, vertical axis, and coincidence. Now this center also lies on the pitch circle. So I will select the pitch circle and the center of circle and apply the constraint of coincidence. Okay. So coincidence, and the diameter of that circle is 20.3. Right. This is my construction element. So I will convert that pitch circle into construction element by selecting the construction tool from sketch tools toolbar. Hole is green, right? So use pocket command to remove the material up to last, because the hole is throughout. Now I will make use of circular pattern from transformation toolbar. Number of instances are 3 in the complete crown. Okay, so I have chosen wrong pattern. It is circular pattern. Number of instances are 3 and parameters complete crown. Reference element is this circle and object to crown is this one. Object to pattern is that hole. Okay, let us check the diameter of hole. It is 20.3. Okay, 20.3. So we are right. So this is my retainer. There is one more circular hole at the center of this retainer having diameter of 56. We'll select this as my sketch plane, sketch tools, circle is concentric with this circle. Okay, so concentricity and diameter of this circle is 56, right? Okay, remove the material up to the last. Okay, this is my retainer. The next component is arm. So let us save this retainer in the same folder. I will close this, start the new file. I want to draw this arm, so I will name my part as arm. Sketch tools, horizontal plane. For the arm I will draw these 2 circles joined by 2 tangent lines. So I will draw the first circle at the origin. Okay, first circle at origin, second circle on horizontal axis, dimensions this one, and dimension for this one. Let us check the dimensions. For bigger circle it is 112.5 in diameter. So 112.5 in diameter. So 112.5 in diameter, and smaller circle is 87.5 in diameter. So let us change these values. 87.5 in diameter. Okay, 87.5. Now I want to connect this using tangent line. So go to the profile tool, under the line tool, select by tangent line, select this circle and that circle. Again repeat the command, select this circle and that circle. Now the distance between centers of both these circles is given as 300. This is 300. Now let us trim the unwanted elements by selecting quick trim from operation toolbar. I don't want this. Okay, I don't want this. Okay. So this is my sketch on horizontal plane, which is completely constrained as indicated by the green color. Let us add the material on both the sides using mirror extend. Depth of material is 25. So on both the sides I will add 25 divided by 2. So the total depth will be 25. Now again I will select the same plane as the sketch plane. Okay. Let us select same plane as the sketch plane. This horizontal plane as my sketch plane. Now I will draw one circle. Now this circle is concentric with this, or it is aligned with this, so I will use coincidence constraint. Draw the next circle, and this is coincident with this. Okay, I am done. I can exit. Now the sketch is exactly on the center plane, and total depth of these two cylindrical features is 62.5. So I will add the material for this sketch number 2 using pad command, using mirror extend on both the sides. Total depth is 62.5. So I will add material on each side equals to 62.5 divided by 2. Okay, so the total depth of material is 62.5. Now we have these two holes on both the cylindrical features. Okay, so let us produce those two holes. Select this top surface as the sketch plane, sketch tool, circle, 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 circle. This circle is concentric with this. Okay, and this is concentric with this. So apply the constraints of concentricity to both these circles. This is concentric with this. Okay, let us give the dimensions. Now we'll modify the values of these dimensions. Let us check what are the dimensions of hole. On the smaller cylinder it is 43.8 in diameter. So 43.8 in diameter, and on bigger cylinder it is 28.15 in radius. So change the dimension to radius and it is 28.15. Okay, 28.15 is the radius. I have done. Let us remove the material using pocket command up to the last, so that throughout hole is generated. Now next we have a keyway here. You can see keyway. Width of keyway is 12.6 and it is on the bigger cylinder. So 12.6 at 35 from the center. So I will select this as my sketch plane. I will draw one rectangle because the shape of keyway is rectangular. Okay. Now I will constrain this rectangular slot about the horizontal axis. Select this line and horizontal axis and apply the constraint of symmetry. Next, distance of this edge from center is given as 35. Let us check it. It's 35 and the width of this keyway is 12.6. So dimension and width is 12.6. Let us take this into hole. Okay, now I am done. 35 and 12.6. So let us go. Remove the material using pocket command and type as up to the last, so that throughout keyway is generated. So this is my arm. Okay, I'm done with the arm. So next my part is plate. So let us draw this. It is an elliptical plate. So we'll name the part as plate. Go to the sketch, select the horizontal plane, then I will select the ellipse command from the profile toolbar. Select the center of ellipse at the origin. Place the extension of major axis and extension of minor axis. Okay. Now let us give the dimensions. So this is major axis radius or major axis diameter. I want to specify major axis radius, which is given as 102.5. So 102.5 is the radius. Okay. So 102.5 is the radius. Now semi minor axis. Again the radius value is given, so I will change the dimension to radius, and it is 96.9. 96.9 is the semi minor axis and 102.5 is the semi major axis. Select the ellipse, select the vertical axis and specify the angle as 90 degrees. Now I completely constrain this ellipse. Now I have two holes on this ellipse having diameter of 12.5. Right, let us check the dimension of that hole, as it is 12.5 and it is on the semi minor axis, which is vertical. So I will coincide this. Now I want one more such hole on the opposite side. So select the hole, click mirror from operation toolbar and select the horizontal axis. Now let us specify the distance between centers of both these holes. It is given as 100. Okay, check it. It is given as 100. 12.5, two holes, 102.5 and 96.9. So we are done with the ellipse. Exit, add material, mirror extend to add material on both the sides, and the thickness is 6, so 3 on each side. So this is my plate. And next we will draw the screw. I will save this plate, save by the name of plate in the same folder. Okay, and close these, start new mechanical design, part design, and now my part is this screw, so I will name that part as SCREW, screw. Select the sketch plane. I will select the vertical plane as my sketch plane. Now this is a revolving element, so we will draw its profile first. So I will select the arc command. Okay. I will select the arc command and I will draw that arc from this vertical axis. Okay, and profile from this point towards the origin, then down and towards the vertical axis. Okay, done. Now I will constrain center of this arc with the origin of coordinate system using constrain command of coincidence. I will dimension this arc with radius of 15 because it's given as 15. Okay, now this length is 38 and this is 20, so this is 38 and this is 10. Okay, this is 10 because total diameter is 20. So my profile is ready, grading color completely constrained. So I exit the sketcher and apply the tool of shaft, which is in sketch based features. So profile is already selected there, you can see here. Now I want to select the axis. Let us select the vertical axis. So we have the screw here. Now this end of the screw has a chamfer, so I will select that edge and chamfer is 3/45. Select the edge, go to the dress up features, select the tool chamfer and enter the dimensions of chamfer 3/45. Okay. Now we'll select this vertical plane as a sketch plane, select the sketch tool. Now we are drawing this slot having a width of 4 millimeters. So I will draw the rectangular slot on this vertical plane. Let us constrain it about the vertical axis using symmetry command from the constraint definition toolbox. Width is 4, and height of edge of this slot from this edge is 3. Okay, so I'm done. I do not care about this height until it is above this material. Okay, now I have drawn this profile on the central plane, so I can remove the material using pocket command on both the sides using mirror extend option from pocket definition dialog box. Okay, here is my slot and this is my screw. Let us save this screw with the name of screw itself in the same folder. Now I will close this. Now we will draw one more screw that is also required in this assembly, having diameter of 12.5 because it is going to assemble in this hole. Okay, so start mechanical design, part design. I will name this screw as screw 22. Okay, sketch plane, vertical sketch plane. Let us first of all draw the profile of the revolving feature, this one, then profile tool. I will go in, will come down about the vertical axis. Center of this arc is at the origin, coincide. Radius of this arc is 15. Okay, this is 38, and now diameter is 12.5. That means radius should be 12.5 divided by 2. Now I am ready to apply the shaft command from sketch base features. Select this axis. Now I will fillet the bottom edge, chamfer the bottom edge using chamfer command from dress up features. So enter the dimension as 1 by 45. Now let us produce that slot in the pin. So select the vertical plane as the sketch plane. Select the sketch tool. Draw the rectangle. Select these two vertical lines and make them constant about the vertical axis. Using symmetry tool from constraint definition dialog box. Width of this is 4 and distance of this edge of slot from this edge is 3 millimeters. Okay, so done. The sketch is on the center plane, so we'll remove the material using pocket tool from sketch based features toolbar and using mirror extend option from pocket definition dialog box. So this is my screw number 22. Let us save this with the same name. Now last component is nut, which is hexagonal. So start mechanical design, part design. I will name my part as nut. Select the sketch tool, select the horizontal plane, take the command hexagon from profile toolbar, select center of the origin as center of hexagon and place the hexagon on vertical axis. Dimension it. Distance between these two edges is 69. Okay, let us check. It is 69 and the depth of material is 25. So I am done. It is green. So I will add the material using pad command on both the sides. It is total is 25. So 25 divided by 2 on each side. Now next we have to fillet it using this radius of 100. Before that, let us select this sketch plane, then sketch tool. Okay, then I will project this edge using project 3D elements from operation toolbar. I will also project this vertical edge using the same tool from operation toolbar. Then go to the profile tool, draw one arc. Okay, make this arc tangent to both these elements using constrain tool of tangency. This is also tangent to vertical edge. Okay, now we will remove one of the constraint and specify the radius. Okay, I will remove this. Now, radius of this arc is 10. Now I will remove the unwanted elements using trim tool from operation toolbar. I don't want this and I don't want this. Okay, I don't want this. I am ready. Let us check the radius. Yes, it's 10. My sketch is green. I can exit the sketcher. Now I will use glue command to remove the material by revolving the feature or profile. I will select the vertical axis, and this is how my nut is ready. And there is one hole on this surface, so select that surface as sketch plane, sketch tool, draw the circle. Dimension of that hole is, let us check, it is 37, and center of this circle is at the origin. So coincide. Let us check, 37 is its diameter. So change the dimension type to diameter and change the value to 37. Got it? Then pocket up to last. And here is my nut, which is ready. Okay. So we'll save this, the name of nut, in the same folder in which all the components of butterfly valve assembly are there. So we have done with the part modeling. We have produced solid models of all